Continuing on, even more expanding brackets. It is pretty important, so we need to do lots of them. I'm going to do these ones in a nice blue colour just to make you feel all at home. Okay. If you ignore my terrible spelling, terrible handwriting there, it's everything in this bracket times everything in this bracket. When I mean everything, I mean each term times each term in this bracket. So let's do the first term. 3x times x is, of course, 3x squared. Minus 2 times x is minus 2x. We've done the first term there. First term times the last term. 3x times 5 is 15x. And last term times last term. Negative 2 times negative 5 is negative 10. Remembering your addition and subtraction, multiplication rules. 3x squared is the only x squared. That's that done. We combine the x's by themselves there. Negative 2x plus 15x is plus 13x, and the negative 10 is the only constant, so it comes through in the end. Okay, let's try this one. Two x minus 3 x minus 6. Nothing should scare you. Let's do our FOIL method. First, 2x times x is 2x squared minus 3 times x is minus 3x. And now the last term, 2x times negative 6 is negative 12x. And lastly, the negative 3 times the negative 6 is positive 18. Remember, a negative times a negative equals a positive. So collect up the terms. 2x squared, that's the only x squared term. Now we have these two like terms here. Negative 3, negative 12 is going to be negative 15x plus 18. Okay, one more. Four x plus 1 x minus 2. Again, nothing should really scare you. First, 4 times x is 4x squared. X times x is x squared. Plus 1 times x, well, that's going to be plus x. And we have first term times the last term there. 4x times negative 2 is negative 8x. And then 1 times negative 2 is -2. So we end up 1x minus 8x is minus 7x, and then the -2 comes down. Okay, what about this then? X plus 3, and shouldn't be scaring you. What about if I squared the whole thing? What does that actually mean when we put an indices or an exponent there? Well, if we had a, where a is any number, and we had it squared, it would be the same as saying a times a. So x plus 3 to the power of 2 is exactly the same, if we wanted to rewrite that, as x plus 3 times x plus 3. X plus wonky 3 in this case. Same thing. X times x is x squared. 3 times x is 3x. X times 3 is 3x. 3 times 3 is 9. And our final answer will be x squared plus 6x plus 9. This is a special case. There is a little formula that does that in shorthand. It's a nifty little formula to have at your fingertips. Not essential, but if you notice that it does kind of work for this one. If the a here is x, a squared, 2 times x times 3 is 6x, and b squared, the b was 3, is 9, so it works for this one as well. Just a handy little tool to have up your sleeve. Okay, how about this then? How about this one? X plus 5 x minus 5. Right, let's solve it using our old tried and true method. X times x, x squared. 5 times x is plus 5x. X times -5 is -5x, and 5 times -5 is -25. Can we simplify it? Yeah, we can simplify it. X squared stays as it is. Now 5x minus 5x is no x, so the 25 comes down here. Now, do we notice anything interesting in this case? This is a very, very important concept. This is called the difference of two squares. if we have the difference of two squares, so say we have a squared minus b squared, we can always rewrite that as a plus b, a minus b. And if we look up here, x squared minus 25 is a squared. It's a nice square. X squared minus 25 is the same as saying x squared minus 5 squared. So we could have jumped straight to the end result, x plus 5, x minus 5. Which is what we actually started with there. It's just a really, really important trick to have. It's come up in exams quite a bit, and you'll be using them quite a lot later on when we get to graphing. So just kind of keep it up your sleeve there.